We are now doing question 2 of the 20. Let us start doing question 2, and we have 2.1, which says we are given an arithmetic series. The series is 18 plus 24 plus 30 plus up to 300. Okay, then the task says that we are required to determine the number of terms in the series, meaning we are required to find the value of n. So how do we find the number of terms of this series? Provided that we have been told that the series that we are working with is arithmetic series. So in order for us to find the number of terms, we want to find the location of the last term because we are given the last term. So first thing first, we have to find a general solution or a general term for this series. So we are told that we are working with an arithmetic series. So a general term can be found by this arithmetic series formula, provided that we know the first term, that the first term is 18. By the way, we know the last term, of which is 300. What we want to find is where is this 300 located, and n minus 1. By the way, n is the unknown, and when it comes to a common difference, we want to T3 minus T2. If we can prove that T3 minus T2 is equal to T2 minus T1, then we will be having a common difference. This is the formula that we use in order to get a common difference. So 30 minus 24, it is 6, of which is term 2 minus term 3. Term 2 minus term 1 is equal to, in fact, term 3 minus term 2. And then now term 2 minus term 1 is equal to 24 minus 18, and it gives the very same value 6. 6 is equal to 6. That means we have a common difference. So here instead of t, we write 6. So 300 is equal to what? 18 plus, you have to use the method of bracket of n times 6, it will be 6n, minus 1 times 6, it will be minus 6. So now I have 300 is equal to 18 minus 6, 12, plus 6n, and then I take this one to the other side. I have 300 minus 12, which is equal to 6n. Okay, and then 300 plus 12, so by the way, it was positive, and then to the other side having a minus 12 is. So now I'll be having 288, which is equal to 6n, and then I divide both sides by 6. Then n is equal to 48. So this is the value of n that we are looking for, of which is the number of terms. So that means we have 48 terms here in this series. And then moving forward, now we go to 3.1.2. And our 3.1.2, not 3.1.2, 2.1.2, by the way. Okay, 2.1.2. Here we are required to find, to calculate the sum of the series, and we are given 2 marks. So on your formula sheet, you have sum of the arithmetic, which is equal to, so on your formula sheet, you have 2a plus into n minus 1 times t. This is the formula that we have, and another one is this one, which is n over 2, and then we have a plus a last term. So we use this one if last term is not given. That means you just have the terms that are not being shown, where do they end. And this one, we use this one when we are given what? Last term. So in our case, We are told that the last term of this series is 300. So by the way, we will stick with this one. So we have S, and we want to find the sum of all the terms. We know the terms are 48. So it will be 48 divided by 2. And then the first term here is what? Our first term is 18. And then we have 18 plus 300. Okay. So what do we have? So our summation of 48 terms will be, when you say 48 divided by 2, you get 24, and then you open bracket here, you have 218, and then when you multiply the 2, you get, use your calculator, as 48 is equal to 7,632. 7,632. Okay, then the next question says, okay, it's 2.1.3 now. Okay, this one is a bit tricky. We are required to calculate the sum of all the whole numbers up to and including 300 that are not divisible by what? By 6. This one is a bit tricky. But in order for us to get the solution, look at this. If you can pay a close attention, the arithmetic series that is given to us is the series of multiples of 6. So that means all of these numbers that are on this series are divisible by 6. So meaning for us to get numbers that are not divisible by 6, in fact, we have to find the summation of all the whole numbers. You get my point? We have to find the solution of all the summation of all the whole numbers, and then from there we have to subtract those that are divisible by what? By 6. So what we know is that 300 as the last term is divisible by 6, and 300 is included. That means we are counting from 1 up to 300. Okay. In our case, we are no longer, or we are not going to work with this sum of the terms, but we are going to include all terms that are divisible by 6 when we talk of whole numbers. Okay, so let us go into details here. We have 2.1.3. Okay, let us calculate sum of what? Of whole numbers. When we talk of whole numbers start from 1 up to 300. So meaning they have a common difference of what? Of 1. So, okay, first thing first, we want to write this series. We have 1, of which is the whole number, plus 2, plus 3, plus 4, plus plus 300. All right. So if you look carefully, if you want to find the common difference here, of which is t, is equal to what? 1, because you'll be saying t3 minus t2, t2 minus t1, then you'll be getting 1. That means we are working with an arithmetic series. What is next? Okay, in our arithmetic series, a sum, okay, n over 2, and then we have first term plus what? Last term. Do you get me? So in this case, we are looking at 300 terms. So to be sum of 300 terms, of which is 300 divided by 2 into the first term is 1 plus what? 300. So in our case, 300 divided by 2 is 150 multiplied by 301. So 150 times 301, the result is for the 5,150. That is sum of 300 terms, of which is the whole numbers. Okay, now when we look at those that are divisible by 6, remember 6 is divisible by 6, plus 12 is divisible by 6, plus 18 plus 24 plus plus 300, because we know that we end up to what? Up to 300. So now I want you to pay attention here. In the summation of the series, we were summing them all, not starting from the smallest number that is divisible by 6, but we started by 18. So there are two more terms before 18 that are divisible by 6, of which is 6 and 12. So that is why I did not use this information, of which is this information that is here. Okay, I hope I made myself clear. So in this case, you see that the common difference will be 6, because you'll be saying 12 minus 6, you get 6. 18 minus 12, you get 6. 24 minus 18, you get 6. Okay. So in this case, what does that imply? That implies that we are also working with arithmetic what? Series. What do we do if we have arithmetic series? And we also have the last term. So this implies that the sum of terms, remember now, we said that number of terms in this case, there are 48 terms, but remember that I've added 2 more terms, of which is 6 and what? And 12, which makes sum of all the terms no longer to be 48, but I've added 2 more terms. So number of terms now, they are 50. So 50 is equal to number of terms. But by the way, identifying n, of which is the number of terms, n is 50 now. All right, so since now I know that on my series, I have a constant difference, what does that imply to me? That tells me that I have to work with an arithmetic series, of which is the series that consists of 50 terms. So in our case, before I even write 50 terms, let me start by writing the formula first. On your formula sheet 1, the first question that you'll be asking yourself is that, am I given the last term? The answer is yes, this is our last term. So that implies that I can work with this formula. So it's a plus what? Last term. But what if the last term was not given to me? I was going to use an alternative method. But this is the one that you use if you have a last term given to you. So in this case, I know that terms are no longer 48, but they are 50 now. So it will be 50 divided by 2, and my first term in this case is 6, plus my last term is 300. So 50 divided by 2 becomes 25 into 306. So when I say 25 times 306, the results becomes what? It's 7,650. Okay, so now come back here. I haven't answered the question yet, but I'm about to answer the question now. I have to get all the numbers that are not divisible by 6. I know the sum of whole numbers. I know the sum of numbers that are divisible by 6. So since I'm looking at the whole numbers here, this is what was required to, okay, it is sum of those that are not divisible by 6. You get my point? Is equal to sum of all whole numbers, of which is sum of 300 numbers, minus by sum of those that are divisible by 50. So in this case, sum of whole numbers, it will be 45,000. It's 45,150, and then minus by those that are divisible by 6, of which is 7,650, and then the result will be 37,500. So 37,500, those that are not divisible by what? By 6. I hope you did not get lost, but if you have any questions or you are not satisfied elsewhere, just write on the comment section. I will then address your queries. Okay, then moving to 2.2. Okay, 2.2 here. Let me use this color. Let me use purple. Okay, let us go to 2.2. 2.2, I am given the statement here that the first three terms of an infinite geometric sequence are of 16, 8, and 4. So it's 2.2. 2.2, here I have this geometric series of what? Of infinite. You can think of something when someone speaks of infinite sequence. Okay. So I'm given what? A first three terms of which is what? Is it not 18? Yeah, it's 16. So these are the terms here. I have 16. I have 16. I have 8, and I have what? I have 2. Not 2, but 4. I got 4. I have 4. Yeah. Okay. Okay. So the question says that the first question is 2.2.1. Determine the nth term of the sequence. One, I'm told that the sequence is what? Is geometric. But I can just continue. But in this case, I'm told that it's geometric, meaning this is what I want. T3 divided by T2, of which is 4 over 8 is equal to 1 over 2. And then let me look at T2 divided by T1, of which is what? 8 over 16, of which is what? 1 over 2. By the way, my ratio is common. It's both equal to half. So in this case, if they want, is it a general term? Let me check. Yeah, it's an nth term, so it's a general term that they need. So this function or this sequence is exponential, and it is of this form. It is of this form, ar to the power of n minus 1, where the first term in our case is 16, and the r in this case is half to the power of n minus 1. Are we done? I'm not happy with this one. Can we continue? Yes, we can. We can rewrite 16 as 2 to the power of what? Of 4. And we can rewrite half as 2 to the power of minus 1 into n minus 1. I hope did not mislead you anyhow. So now if you can look carefully, okay, let me start with this one. 2 to the power of 4 times 2. When I multiply the exponent, I'll have minus n plus 1. But if you can look carefully here using your laws of exponent, you can see that now I have powers of what? Of the same base. So I can just drop one base and add what? Their exponent. So I can just say 1 plus 4 minus n. So in this case, I'll be having 2 to the power of 5 minus n. So this is my general solution. You can leave it like this also. Okay, so this is my general term. I hope I did answer the question. Even though it is 2 marks, but I'm just giving it all the details so that when you can understand when you just browse at the problem. Okay, and then the second question says that determine all possible values of n, for which the sum of the first n terms of the sequence is greater than what? 31. 1, there's a sum involved. Okay. And 2, I am told that I'm working with infinite geometric sequence. All right, what does this thing leaves me? This thing leaves me at the point whereby whenever I talk of sum, I have to know the formula or the exact formula to use. In this case, the right formula to use, okay, here I did not write that is 2.1.1 is 2.2.1, so now is 2 or in 2.2. Okay, so sum to infinity is a over 1 minus r. Remember, I know the value of r is half, and I know the value of a is 18. But this is not the case. I have to find the value of n. So, do I have the value of n here? The answer is no. How can I get the value of n? I can get the value of n when talk of sums, when I work with what? With a geometric series with this general term Sn equal to a into 1 minus r to the power of n over what? Over 1 minus r. And one will ask, why now am I using this one where when I'm told that I'm working with an infinite geometric series? No. In this case, you are being given that they just want you to get that certain finite number of terms, so they are no longer infinite. You will be asked to count the sum of these infinite terms, but in this case you are now being bounded or being restricted to the section that is finite. So in this case, you want sum of n to be greater than what? 31, if I'm not mistaken. So here, look here carefully. Okay. If you can look carefully here. Okay. Determine all possible values of n for which the sum of the first n terms of the sequence is greater than what? 31. Okay, so I need the value of n here. Okay, how am I going to reach there? Okay, my screen is a bit lazy, but I will be patient with it. Okay, so this is what I'm told, that n has to be greater than what in order for us to exceed 31. Okay, Sn says what? We have a into 1 minus r to the power of n all over 1 minus r, of which is greater than what? 31. Okay, I know the value of a. The value of a is what? Is a is 16. Let me check whether today. Oh, it's 18 in this case, not 16, it's 18. Okay. The value of a is 18 into 1 minus, and the value of r is what? Is half to the power of what? N. And I don't know n. Divided by what? By 1 minus half. So it has to be greater than what? 31. Okay. 18 into 1 minus half to the power of n all over 1 minus half is half. So it's greater than what? 31. Okay. Now let me divide this one. When you say 18 divided by half, you will get still punching my calculator, will get 36. So it is 36 times 1 minus half to the power of n greater than 31. Okay, one can just divide by 36 both side, but let me not do so. 36 times this one will be 36 minus 36 times half to the power of n greater than what? 31. Okay, checking this one to the other side and this one to the other side. So it will be 36 minus 31 is equal to 36 times half to the power of n. So what will I get here? I will get 5 is equal to 36 times half to the power of what? Of n. Okay. So there is no possibility of writing 36 in terms of 2. So by the way, what is remaining now, I have to divide both sides by 36. So it will be 5 divided by 36 equal to half to the power of n. Okay. And then if I can just introduce a log here, multiply by a log both sides. Okay. So I will end up with log of 5 over 36 is equal to n log of what? Of half. So n is equal to log of 5 over 36. Okay. So log 5 over 36 divided by log of half. So what will be the solution?